Alright, today we're going to start video 2 on the properties of water. And you've got your Frayer cards, which you notice that the keyword is in the center of the box. And then you have a place for a diagram, a definition, a sentence, and an example. During the note-taking process, you want to get your definition and possibly your example done, maybe your diagram, but make sure you get a definition down. When we finish these 9 definitions, we're going to do a lab, and we'll start it today and finish it tomorrow, called the magic molecule. And from that, you'll be able to go back and work with your partners to make sure you have a sentence using the word as well as anything else that's missing. But make sure you get the definition today. Now, we want to start with the definition for polarity. And water is, remember, a molecule of H2O, which means 2 hydrogens and 1 oxygen. And those 2 hydrogens are smaller atoms. Remember, they only have 1 proton, no neutrons, and 1 electron. And oxygen has 2 electrons in its outer level. So that oxygen atom is very attracted to those 2 hydrogen atoms. And the way hydrogen attaches to oxygen, the structure of the molecule, gives water this sticky quality. It's very attracted to other substances. That's why water dissolves so many substances. It makes so many different solutions. And water's polarity, the structure of its molecule, this attraction between the hydrogen and the oxygen, gives it kind of an electric buzz or charge. It's always ready to realign with something else, and that's polarity. And we're going to stop here and see a little clip. Now, buoyancy is the upward force that keeps objects afloat. So you've seen inner tubes, you've seen rafts, you've seen other people floating on their back, boats floating, and that's just the push of water up on the object keeps it afloat. And density plays a role in that. This is some salt from the Dead Sea, and which is the saltiest body of water on the earth, saltier than the ocean. And you can see here it's packed down into rock form, and here it's still in crystal form. But you can't sink in the Dead Sea because of the salt and the buoyancy. And if the buoyancy is greater than the weight, then the object will float. If the object's weight is greater than the buoyancy of the water, then it will sink. The next property is density, which this should be a review. Remember, density is just a ratio that compares the mass to the volume. Water has a density of 1.00 grams per cubic centimeters, so that is why it's a comparison for many things that will sink and float. Surface tension is how water molecules are attracted to each other. Water molecules, again, remember that polarity, they are sticky molecules. They stick to each other, and they create what's called surface tension, and which means that at the surface, the water's sticking together, so when you break the surface, if you break it gently, not like a belly flop, but a nice swan dive, there's not much of a splash. It also means that some organisms who have a well-designed foot that actually is more like a boat, they can walk on the water. The water strider is an insect that appears to walk on the water because it barely breaks the surface tension. The Jesus Christ lizard, which we're going to stop and see a little clip of him right now, he does the same thing. The design of his feet and his speed, he is able to glide across and barely break the surface, and so he doesn't sink there. He appears to walk on the water. And you're going to do one of the demos. You're going to get to play around with that idea. Here you see a computer-generated picture of surface tension. He is buoyant, he's floating on the water, and you also see like the layer of the surface of the water up over his face. So he is barely breaking the surface. All right, the next property of water is very important for plants. Photosynthesis, we know that most water comes into the plants through the plant's roots. Excess water, it can be transpired back out through the stomata. But through the roots, the water travels down into the ground and then it travels back. Gravity causes it to go down, but how does it go back up? And it's the force or the property of capillary action. So water can travel upward, and that's very unique to get it to the stem and the leaves so photosynthesis can take place. Adhesion. Have you ever, especially in the summer when it's warmer, you might have a glass with a lot of condensation on the outside, a lot of water drops on the outside, and it's sitting on a coaster on the table, and you pick it up and the coaster comes with it. That ability of water to stick to other materials is called adhesion. And we're going to pause right here and see a little video clip as well. Water is also called the universal solvent. Universal because it can do so many different things. And what it can do well is it can dissolve so many substances. So when you think about sugar and you think about salt, you think about coffee, you think about tea, you think about lemonade or Kool-Aid mix, anything that dissolves in water, it's based on the polarity of its molecules, the stickiness of those molecules, the slight attraction that those molecules are attracted to other substances. And so water is the solvent, what's doing the dissolving, and then whatever's being dissolved in it is the solute. And so water is known as the universal solvent. Another property of water is cohesion. And because of cohesion, we do have surface tension. All water molecules stick to each other. At the surface, when they stick to each other and make that surface that's, when you slide in and break through, it can have a low splash rate because of surface tension, or the lizard and the water strider can walk on the water. Talking about down deep in, again, all the water molecules want to stick together. So it's an attractive force between, and you're going to do an activity either today or tomorrow in the Magic Molecule Lab where you're going to see how many drops of water you can pile on a penny. And so the first layer of water molecules piling on the penny is adhesion. They're sticking to the copper penny. And then you're going to keep adding drops, and they're going to build up, and they're going to make a curved surface above the penny. And we call that curved surface of water the meniscus. And it's due to its cohesive properties, its ability to stick to itself. And then the last property, notice that this goes down the box. Down at the bottom of the page is specific heat. Water has a huge specific heat. It is very slow to gain heat. It is very slow to lose heat, which is why you can go to the pool in June or the beach in June, and it may be 80 or 90 degrees outside, but the water temperature is still cool because the large body of water is slower to warm up. Same reason you can go to the beach the end of September, and the air may be cooler, but the water is still warm. Water is slower to lose its heat. That's why you can go to the beach in the middle of July when the water has warmed up. The water may be 70 degrees by July and maybe 98 degrees outside, and the water is nice and cool, feels good to you, and then you step out on the sand and the sand is very hot. The sand has a much lower specific heat, so it gains heat energy much faster than the water does, and the water is still comfortable. Now, we're going to start the lab where you're going to get to see examples of each of these properties. And when we see the examples, you should be able to go back, add diagrams from the lab, add examples that you didn't get during the notes, and come up with, you and your group members come up with a sentence showing me that you can use the word correctly. But please do not repeat the definition. That's not using it correctly in a sentence.